Okay, our next step in the process of learning how to use the Pythagorean Theorem is going to be finding a missing leg. So title these notes, Pythagorean Theorem. Find the missing leg. Okay, so here's what that looks like. We have a triangle. Here's our right angle. This side is A. This side is 4. And the hypotenuse is 5. When missing a leg, measurement, we're not talking about pirates, we're talking about triangles. That was a bad joke. When missing a leg measurement, substitute known lengths into the formula and solve. So if you're missing a leg, then you're going to substitute everything into the formula. We'll be using the same process as we did last time, except in this case, I know the B and the C. I just don't know the A. So get that copied, and then we're going to take a look at this example. So call this example 1. Copy the picture of the triangle with the measurements. Copy the note that I wrote, and then we're going to actually work this out. Okay, so let me erase this. So underneath the note that we just wrote, we're going to work through this problem here. So if I have a squared plus b squared equals c squared, I know the b and I know the c. I don't know the a. So I'm going to keep the a squared. My b squared is going to become 4 squared. My c squared becomes 5 squared. So what we're going to do is we're just going to solve this as if it was an equation. If I just had a plus 4 squared equals 5 squared, I would say a plus 16 equals 25. I would subtract 16 from both sides, and I would end up with a equals 9. Now the difference here is I do have an a squared. Just because my a is squared means that it doesn't mean any different when it comes to solving this equation until the end. Once we get to the end, then we've got an extra step to find a instead of a squared. Okay, so again, if we look at my process, I didn't do anything different than if it had been a plus 4 squared equals 5 squared. The only thing is my last step here is going to be find the square root of a squared and the square root of 9. And I end up with a equals 3. So the only thing different that's happening is that we have one extra step at the end where we've got to solve. Okay, let's take a look at another example. Okay. My next example, we'll call this side 15, the hypotenuse 17, and I do not know this side. me just make this a little more clear. Okay, so my formula is a squared plus b squared equals c squared. And I'm going to substitute. My a will have 15 squared. Don't know my b. I'll leave that b squared equals c squared, which is 17 squared. Okay, so we'll take out your calculator. 15 squared is 225 plus b squared equals 289. Go ahead and solve our equation. Start getting that b by itself. And I get b squared equals 64. Then I need to take the square root of each. Square root of b squared equals b. Square root of 64 is 8. Awesome. Next example. What happens when things do not work out perfectly? Okay, so copy this triangle down. One leg is 5, the other leg is a, and my hypotenuse is 9. So I'm going to have a squared, my b is 5, so plus 5 squared equals c, which is 9 squared. We'll go ahead and simplify my squared numbers here. So I get a squared plus 25 equals 81. Subtract 25 from both sides. And I get a squared equals 56. Find the square root of each side. Now 56 is not a perfect square, so I need to find the square root, and we'll round to the nearest hundredth. So I'm going to use my approximation symbol. A equals approximately 7 48/100ths. Okay. Okay, next up we're going to take a look at a word problem. Now, this is not a real world problem. We will be looking at real world another day, but there is something that you're going to see on your test that I definitely want to take a look at. Copy this down. Two sides of a right triangle have lengths of square root of 5 units and square root of 10 units. There are two possible lengths for the third side. Find both lengths. Okay, I want you to think about this for a minute. There are two sides of a right triangle that have lengths of square root of 5 units and square root of 10 units. There are two possible lengths for the third side. Find both. So here's my question for you. Pause this if you want to try it without hearing any kind of hint. So if you don't want to hear any hint, pause now and see if you can figure it out. Now here's a hint. It tells you two sides of the triangle. It doesn't tell you which two sides. Now remember, there's a leg and a hypotenuse. The leg are the two sides attached to the right angle. The hypotenuse is across from the right angle. Every side is called a side. So there's no specification of whether these are the A and the B or the C. So we can take a look at this and we can say my sides are square root of 5 and square root of 10. My triangle has three sides, the A, the B, and the C. Now I know the C is the hypotenuse and it's the longest side. So I could say that A is square root of 5 and C is square root of 10. And then we find the B. My other option for my A, my B, and my C doesn't tell you what everything has to be. So I could say that my A is square root of 5, my B is square root of 10, and I don't know what my C is. So again, because they didn't specify what a leg was and what an hypotenuse was, as long as if you choose C as one of the sides they give you, it's the longer one, you're fine. Okay, so these are your two options. I want you to go ahead and pause and figure out the two possible lengths. Okay, so this might have been a little bit tricky because we have square root numbers, but let's take a look. So this first one, I'll say a squared plus b squared equals c squared. Now, square root of 5 times square root of 5 actually equals 5. If you square root a square, you get the number. If you square a square root, you get the number. So what's happening is the square root and the square are canceling each other out. So the square root and the square, they cancel each other. Okay? So I'm left with 5 equals, 5 plus b squared equals 10. Subtract 5 from each side. B squared equals 5. Square root each side, and b would end up equaling square root of 5. So that's my first option for length. My second option, I'll try to write a little smaller here. Square root of 5 squared, that's my a squared, plus b squared equals c squared. If I square the square root of 5, I get 5. Remember, this is like saying, just a little another side note. This is like saying square root of 5 times the square root of 5. If I take the square root of 5 times the square root of 5, I end up getting 5. Okay. So I get 5 plus 10, because the square root of 10 squared becomes 10, equals c squared. 15 equals c squared. Square root the left, square root the right, and I get square root of 15 equals c. So if one leg is square root of 5 and one leg is square root of 10, then my c will be square root of 15. All right, here's the last thing we're going to do to wrap up the specifics of the Pythagorean theorem. I want you to draw this model on your paper. This is going to take up, I would say, at least, take a look and see what it looks like first so I could tell you how big it's going to, so you can decide how big it's going to be. The middle will say Pythagorean Theorem. And what's going to happen inside is you're going to put the words for the Pythagorean theorem in this box. So you're going to write the word words, and then you're actually going to write here. You have the words in your notes. Just a little side note there for you. Then in this corner, you're going to write visual. In the visual section, you would put in some sort of maybe the triangles with the area squares on the sides would be a good visual for that. Down here, you'll put the algebra. This is where you'd put the formula. And then you're going to create your own example. So make up your own problem to put in the example area. So I would say each of these probably needs to be at least 6 lines of your notebook, and probably the width of your notebook, but you know you're writing better than me. So again, in words, you're going to put the definition. Let me change my color here. Then here you're going to put a picture, probably like the proof. That's the one with the area squares on the sides. This will be the formula, and this is going to be make up your own. So don't write what's in the green. That's just a little tip for you. So you fill this graphic organizer in on your notes, and that's it. You're done.